This is a college algebra problem where we're asked to solve the quadratic inequality and then write the solution set in interval notation. So our inequality is 2x squared plus x is less than or equal to 15. Let's first solve the corresponding quadratic equation, and let's get it set equal to 0 by subtracting 15 from both sides. So we'll have 2x squared plus x minus 15 is less than or equal to 0. All right, factor what's on the left. We know we'll have an x and an x. We have a 2, so one of them will have a 2 on it. And then you've got the 15. So 1 and 15 or 3 and 5 would be factorizations. If we pair the 3 with the 2, we would get 6. And then 6 and 5 combined can give us a 1. If we make the 3 positive and the 5 negative. So for all to check, first you have 2x squared. Then outside is 6x. Inside is minus 5x, which combine to make the x, and then minus 15. So that is our factorization, but let's do the equation, not the inequality. Okay, so then our zero factor property says that 2x minus 5 has to be 0, or x plus 3 has to be 0, if they multiply to make 0. Solving the one on the left, we would have x equal, add 5 to both sides and divide by 2. Or on the right, subtract 3 from both sides and x is negative 3. All right, this is going to break my number line into 3 segments. So let's just get a general approximation for where each of these are located. So that'll be my negative 3. So that would be negative 2, negative 1, 0, 1, 2, 3. So 5 halves would be halfway between 2 and 3. So that broke my number line into 3 intervals. Okay, so we've got the interval to the left of negative 3, so that would be negative infinity to negative 3. Then we've got the one between negative 3 and 5 halves, and the one to the right of 5 halves, so 5 halves to infinity. Now we'll go back to our original inequality and pick a point in each of those different portions of my number line and see which ones make true statements. So to the left of negative 3, let's use x being negative 4. So you'll have 2 times negative 4 squared plus negative 4 is less than or equal to 15. Okay, negative 4 squared would be 16 times 2 is 32, minus 4 is 28, less than or equal to 15 is false. So that one is not in my solution set. All right, then let's try in between. Let's use the 0. So you would have 2 times 0 squared plus 0 is less than or equal to 15. 2 times 0 is 0, plus 0 is still 0. 0 is less than or equal to 15 is a true statement. So this region in between are part of my solution set. Let's try to the right. So let's use, 4 to the right? So we have 2 times 4 squared plus 4 less than or equal to 15. 4 times 4 is 16, times 2 is 32, plus 4 is 36. 36 is not less than or equal to 15. So that one's not in part of my solution set. So my solution set is the region in between, but my inequality has an or equal, so I have to include the endpoints. So my interval notation will be that it's bracket, negative 3 to 5 halves, bracket.